Hi everyone, today we'll be looking at the PLC programming with pneumatic synchronization. Pneumatic synchronization with Advanced Programmable Logic Controller, PLC, programming solutions offers a reliable and efficient way for discrete parts manufacturers to control their production lines. By connecting compressed air cylinders to the PLC through a timing mechanism, the system can easily program to accurately and consistently repeat machine motions or cyclic actions. This is especially valuable for manufacturers who require precise motions and repetitive movements during part fabrication. With all these benefits combined, PLC pneumatic sync programming will significantly reduce production costs while improving overall product quality in automation applications. The 5 steps for PLC programming development will be followed, and we'll show you how to utilize this pneumatic synchronization. EasyPLC Pneumatic Synchronization machine will be connected to the Do More Designer PLC simulator using Modbus TCP or Ethernet. Assembly of boxes will be done from 2 conveyor input lines. The process will then put the complete box on the output conveyor line. Let's get started. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. The first step of PLC program development is to define the task to determine what must be done. EasyPLC software suite contains this pneumatic synchronization example in the machine simulator. This is just one of many machines that come with the software, so you can learn and develop your PLC programming skills. Start the EasyPLC machine simulator, MS. Select the Start button on the main page or select the machines from the main menu on the top of the machine simulator window. All of the available machines will now be displayed. Click on the pneumatic synchronization. This is the example that we will be programming. To the left of the screen, information will be displayed on how this process needs to function. The objective of the assembly process is to make boxes. Boxes come from entrance line 1 and the conveyors come from entrance line 2. Load the boxes onto the mounting tray using the combination of gantry 1 plus the pneumatic cylinder, and gantry 2 and its pneumatic cylinder will load the covers. Mount the lids on the boxes by moving the tray to the corresponding positions so gantry 2 cylinder can mount the lids on the boxes. Return the tray using the gantry 1 cylinder to pick up and position it on the exit line. The machine simulator has a demo mode for this built-in machine. This will allow you to watch the operation of the pneumatic synchronization machine. Select the demo mode. The EasyPLC demo mode on the machine simulator will operate, showing you the basics of operation. Move around this 3D virtual environment. There are 3 icons on the top of the window that will allow you to move around this 3D environment. The first icon is the default selection. This will enable you to move around without bumping into the components. The first person mode will mimic a person in your 3D learning world. The last icon will automatically show you around this virtual environment. Once we have an understanding of what must be done, we can move on to the next step in our PLC program development. The View I/O at the bottom of the machine simulator window will display the inputs and outputs required for this pneumatic synchronization example. While still in demo mode, you can see the operation of the inputs and outputs. The EasyPLC Pneumatic Synchronization example will require 19 digital outputs and 7 digital inputs. Select the analog outputs and inputs in demo mode. Pneumatic synchronization will also require 2 analog outputs and 2 analog inputs. These are used for the movement of the 2 gantries. An output is used for setting the position required, and the input is for the feedback for the actual position of the gantry. Make a note of the 3 positions required for gantry 1 and the 2 positions required for gantry 2. The EasyPLC Start mode will allow you to manually control the pneumatic synchronization simulator. Exit the demo mode and enter the Start mode for this machine. This is ideal if you are unsure as to what an output or input is doing. Select the View I/O at the bottom middle of the machine simulator window. You can manually run the machine simulator without any control or PLC connected. You can now select the pneumatic synchronization digital outputs on the left side of the screen by clicking on them with the mouse. The right side will show you the corresponding digital inputs. Select the analog outputs and inputs. Entering the positions for each of the gantry will show you how the analog output and feedback work. The Restart button at the bottom of the machine simulator window will reset the scene back to the start. Move around the 3D environment and ensure that you know what each input and output represents. A PLC programmer must know everything about the sequence and operation of the machine before programming. The Pneumatic Synchronization Simulator is an excellent way to learn to program. Flowcharts or sequence tables can be used to fully understand the process that needs to be controlled. It must also answer questions like the following. What happens when electrical power or pneumatic air is lost? What happens when inputs and output devices fail? Do we need redundancy? This step is where you'll spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting the PLC program logic. Knowing all these answers to how the system is to react is vital in the development of the PLC program. This does not have to be a formal documentation. You can have any method to account for every condition in the machine being programmed. Our machine has a control panel with beacon lights. If the machine is stopped and ready to be started, the Start push button light will flash. If the machine is running, the red light will be on. The beacon lights will display green if the machine is running and red when it is stopped. If the door is open, the yellow light will be on along with the stop. The machine is reset by pressing the stop button twice within 0.8 seconds. Our EasyPLC Pneumatic Synchronization operation can easily be viewed using a sequence table. At first this may seem confusing. However, the sequence table is read from left to right. If the input conditions are met, the output conditions are set. Let's look at the output table. This will show you the output sequence for the machine. The gantry positions are discrete output in the table. We want to coordinate the movements so that we show the possible gantry positions. Each gantry position output will have a corresponding input position. This will be used to move on to the next step of the sequence. The pneumatic cylinders do not have sensors when they are extend or retract, so timers are used. One timer is used for extending the cylinder, and one is for retracting the cylinder. The input sequence table will show all the possible inputs. A mask allows the sequencing to continue if the input is unknown or does not matter. This is accomplished by ANDing the input channel. This will ensure that the input point is always 0 or off. The PLC programming will involve address pointers. This is sometimes referred to as indirect addressing. V100 will be a pointer to address the input table starting at D100. V101 is the mask pointer starting at address D200. The output table will begin at D500 and the pointer will be V110. A programmer must know everything about the sequence and operation of the machine before programming. Ensure that you know what has to happen will clarify what is required in the PLC program. Ask questions or view existing documentation to ensure that you know the logical steps to the machine's operation. This may involve speaking with the manufacturer, operators, engineers, etc. Using the information from the previous steps, we can now program our DoMore PLC simulator. The BRICS or BRX DoMore PLC series will take you through installing the program, communicating to the controller, providing instructions, and addressing the controller. Select the system configuration under PLC on the main menu. You can also call this up by selecting System Configuration under the Tools menu in the Project Browser window. The computer IP address can be seen under the internal Ethernet port configuration. Modbus TCP server is selected by default, however, we can ensure that this is the case in the system configuration window. Our PLC is now a Modbus TCP server to the EasyPLC Modbus TCP client. Please make a note of a static IP address that we are using for the DoMore PLC. This will be later used to connect to the EasyPLC simulator. The ladder logic PLC programming is split up. It is easier to read and program. We have subroutines for the sequencer inputs, sequencer outputs, and start-stop lights. The main program will call these subroutines and the sequencer using the indirect addressing. Start-stop light subroutine. This first run will control the machine run bit. The beacon and push button lights are controlled based on the machine run bit. Sequencer input subroutine. This section of PLC program will set the individual bits in word D0 for the sequencer input. Gantry 2 positions 1 and 2 are being controlled. If the gantry position is requested, the output for the gantry is set. Once the analog input feedback is the same, the positional input bit is turned on. If the machine stops, the set position comes from the feedback position. This will prevent the gantry from moving. Here are the gantry 1 positions 1, 2, and 3. This will stop the gantry 1 movement when the machine run bit is not on. The work part creating the lids and boxes is on all of the time unless the corresponding input from the inductive switches is activated. This would mean that a part is present. The last of our inputs will be from the tray cylinder and timers. Sequencer output subroutine. This section of PLC program will control the outputs from the sequencer output word D10. Our exit conveyor will be on as long as the machine run bit is on. And you can see all of our different outputs that we are controlling based on our sequencer. Main ladder logic. The start, stop, and light subroutines are called first. Once this is complete, the sequencer input subroutine is called. Here the actual sequencer. The inputs D0 are masked or ANDed together by D pointed to value V101 and the output is sent to D5. The input table D with V100 as a pointer is compared to D5. If they are equal, the pointers are incremented by 1. If the sequencer pointer is greater than the end of the table, the pointers are reset. The pointers can also be reset by double tapping the stop button. Reset the sequence pointers if V10 is greater than or equal to 2. The leading edge of the stop button increments a count in V10. If V10 is greater than 0, timer is started for 0.8 seconds. The next rung will reset the number in V10 if the timer times out. A reset is activated, or the first scan bit of a PLC comes on. This will actually do the reset as well. The last subroutine called is the sequencer output. This will set our actual outputs. The ladder logic program is complete. Download the program to the Do More PLC simulator. Ensure that the controller is in run mode. We can set the input, output, and mass tables using the data view. Test the program. We will use Modbus TCP on our Do More PLC simulator to communicate with the EasyPLC machine simulator. Call up the Pneumatic Synchronization machine in start mode. The status of the machine simulator will be at the bottom of the screen. Currently we have no PLC connected. Select I/O drivers on the bottom middle of the screen. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP or Ethernet and Modbus RTU serial. Select the Configure button. We will now enter the information for our Modbus driver. Select TCP IP. This means the Ethernet port on the computer will communicate with the PLC. The digital inputs from MS to the Do More PLC will be MC1 to MC19. This will start at address 0 due to the offset of 1. Digital outputs from MS to the Do More PLC will be MI1 to MI7. This will again begin at address 0 due to the offset of 1. We are indicating 20 inputs and outputs. This is fine because it's more than the PLC machine simulator will require. Analog inputs from MS to the Do More PLC will be MHR1 and MHR2. The outputs will be MHR11 and MHR12. Due to the offset of 1, the PLC analog will start at address 0 and 10 respectively. Select the OK button. You will now see the inputs and outputs specified for the Modbus driver. We can manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, automatic assignment works well and it will save you time. Select automatic assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the machine simulator I/O. Select Start Driver and exit from the main menu. On the bottom left of the window, you will now see the driver communicates to the PLC with the green light. Select View I/O to know the input and output status of the machine simulator. Ensure that the PLC is in run mode. We can now operate our EasyPLC Pneumatic Synchronization machine. Using the data view window of the Do More Designer programming software, we can watch the inputs and outputs operate. If your program works correctly, it's time to move on. If not, you'll need to debug. Since we are using indirect addressing, troubleshooting and modifying can easily be accomplished. This can be as simple as downloading and uploading your program, or as complicated as redesigning your logic altogether. Amendments to the sequence table and the corresponding PLC sequence tables will quickly change how your logic works. If the sequencer stops at a location, you can quickly see what the input should be enabled and what is currently set. This can be displayed on an HMI for troubleshooting. When using EasyPLC, debugging is quickly done with no damage to any equipment. You may modify your logic several times before you get everything right. That's okay, it's all part of learning. After all, trial and error are often easier said than done. To learn more about developing logic, check out our tutorials on the 5 steps to PLC program development. You can practice your modification and debug by modifying the pneumatic synchronization in the following way. Calculate the cycle time in parts per minute for the machine. Add a jogging circuit for the sequencer. This will allow the operator to manually step through the sequence to troubleshoot the logic and the machine. Let me know how you made out in the comments below. If you enjoyed this video, please hit the like button. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.